Have you ever looked at one of those massive data lakes? You know, the ones that just sort of grown organically over years, maybe hit petabyte scale. And then you get that cold feeling realizing, oh, wow, this thing is packed with sensitive data, PII everywhere. Yeah, and then the real headache starts. How do you possibly clean that up? Make it compliant, make it usable even, without kicking off some huge, terrifyingly expensive migration project that nobody wants to touch.
Exactly. It's a common scenario, unfortunately.
And the go-to answer, the one everyone thinks of first, is usually ETL, right? Extract, transform, load, pull it all out, scrub it, load it back somewhere else, probably a separate masked copy. But when you say petabytes, that whole process just sounds daunting. It sounds less like fixing a problem and more like creating a whole new massive one, a real nightmare project.
It really can be. The scale just changes everything.
So today, we're diving deep into something that could genuinely change how you approach this. S3 Object Lambda, specifically for doing this PII redaction, but dynamically, on the fly. Our mission here really is to show you how this relatively simple AWS service can be a powerful shortcut, a way to get compliant, stay scalable, and ditch those painful, slow, expensive traditional batch jobs.
That's the plan. We want to really unpack how S3 Object Lambda works its magic, how it takes a standard S3 GET request, something applications do all the time, and turns it into this dynamic transformation pipeline right when the data is needed. We'll break down the architecture piece by piece, talk through how you actually set it up, look at performance, cost, and crucially, how it helps with security and those all-important compliance requirements.
Okay, let's really get into it then. You mentioned ETL's pain points, but spell it out for us. When you've got petabytes of legacy stuff and you absolutely have to redact PII, why is ETL such a monster? What makes it so painful?
Well, it boils down to a few core issues that our sources really highlighted. It's slow, obviously. Moving petabytes takes time. It's expensive. You're paying for compute to do the transformation, sure, but you're also often doubling your storage because you create a whole separate redacted copy.
Doubling storage for petabytes. Ouch.
Right. Massive cost implication right there. And then there's the operational complexity. You're building and maintaining these complex ETL pipelines, scheduling jobs, managing failures. It's a huge engineering effort.
And probably a long wait before anyone can actually use the redacted data.
Exactly. Weeks, maybe longer, depending on the scale. So your analysts might be working with stale data by the time the redacted version is even ready. It really slows down the pace of getting insights, which is often the whole point of the data lake in the first place. It's this huge friction point.
Okay, so ETL is this big, slow, expensive, upfront batch process. How does S3 Object Lambda flip that script? What's the fundamental difference?
The paradigm shift is really quite profound. Instead of doing all that transformation beforehand, Object Lambda does it only when the data is actually requested, on the fly.
Oh, okay, so only when someone actually asks for the object.
Precisely. The beauty is your original raw data. It stays exactly where it is in your S3 bucket, untouched, immutable. It never moves, never gets copied just for redaction purposes.
Interesting.
And then when a request comes in, say, from an analytics app, Object Lambda intercepts it, runs your code, in this case the PII redaction logic, and streams back the modified redacted data to the caller.
So different users could potentially see different things from the same underlying object.
Exactly. Your highly privileged auditing team might have permissions to bypass the Lambda and get the raw data directly from the original bucket via that supporting access point we'll discuss. But your general analytics users, they hit the Object Lambda endpoint and automatically get the safe redacted version, all from a single source of truth. No duplication needed.
That sounds incredibly efficient. Almost like magic. But okay, let's pull back the curtain. How does this actually work? What are the pieces involved in this architecture?
It's actually quite an elegant setup using familiar AWS building blocks. First, you've got your legacy bucket. Nothing changes here. This is where your original raw objects live, safe and sound.
Okay, the source of truth.
Right. Then you need a way for the Lambda function to securely access that raw data. That's where the supporting S3 access point comes in. Think of it as a private, secure doorway just for the Lambda function.
And you can lock that down.
Absolutely. You'd typically configure its policy to say, only allow access from this specific Lambda function, or maybe only allow access from within this specific VPC network, adding a strong layer of security for the raw data.
Makes sense. What's next?
Next is the star of the show, the Object Lambda Access Point. This is the endpoint that your applications will actually talk to. It sits logically in front of your legacy bucket.
So the requests go here instead of the bucket directly.
Exactly. It intercepts standard S3 requests, get head list. When a GET request hits this access point, it doesn't just fetch the object.
It triggers the Lambda.
You got it. It invokes your designated Lambda function. This function contains the code to do the work, in our case, the PII redaction. And conveniently, AWS provides a pre-built function for this, the comprehend PII redaction's S3 Object Lambda function, available in the serverless app repo. Makes getting started much easier.
A pre-built function. Nice. And how does that function actually find the PII?
Good question. It uses Amazon Comprehend, specifically its PII detection capabilities. It actually uses two APIs, cleverly. First contains PII entities. Think of this as a quick scan. Does this chunk of data have any PII at all?
Ah, so it can skip chunks that are definitely clean.
Precisely. It's an optimization. If contains PII entity says, nope, no PII here, the Lambda can just pass that chunk through without further processing, saves time and cost. But if it says yes, then it calls detect PII entity.
And that's the one that finds the exact locations.
Right. Detect PII entities pinpoints the specific types and locations of PII names, addresses, credit card numbers, whatever you've configured, so the Lambda can then mask or redact them before sending the data back.
Okay, so legacy bucket, supporting access point for Lambda, Object Lambda Access Point for clients, the Lambda function itself, doing the work with comprehend.
Who's the last piece?
The caller. That's your application, your Athena query, your SageMaker notebook, whatever needs the data. And here's the simplest part for them.
Don't tell me it's just changing a URL.
It basically is. They just switched the S3 URI they were using. Instead of pointing to s3.yourbucket.yourobject, they point to the ARN of the Object Lambda Access Point. Boom.
Seriously, no SDK changes, no complex integration, just point to a different address.
That's the beauty of it. From the client's perspective, it's still just talking standard S3 protocol to an S3 endpoint. They get the data they asked for. It just happens to have been transformed on the way.
Wow. That client-side simplicity that's a game changer right there. Removes a massive hurdle for adoption. It really does. It makes rolling this out to existing systems so much easier.
Okay, I'm sold on the concept. For someone listening who's thinking, right, I need this, what are the actual steps? Walk us through setting this up. Give us the practical how-to.
Sure thing. It's mostly configuration, which is great. Step 1, deploy the redaction Lambda function. Like I said, you can grab the pre-built one from the serverless application repository. Key things here are setting the parameters mask mode mask, so it actually hides the PII, and PII entity types to tell it what to look for, like all L or maybe just SSN credit card number.
Got it. Deploy the function, configure what to mask.
Step 2. Create the supporting S3 access point. This points to your original bucket. Remember to lock down its policy, maybe restrict it by VPC or to the Lambda execution role so only your function can use it to get the raw data.
Security first, okay.
Step 3. Create the Object Lambda Access Point. This is the one your clients use. You'll configure it, importantly, telling it which Lambda function ARN to invoke when it intercepts a request. Make sure you enable it for the right S3 actions, definitely GetObject.
So connect the client-facing access point to the Lambda.
Exactly. Step 4, update your client URLs. This is where your apps, your Athena tables, whatever, stop pointing to the raw bucket URL and start pointing to the ARN of the Object Lambda Access Point you just created. It looks something like https://object-lambda.s3-object-lambda.region.amazonoz.com/per-u.
The simple but powerful step.
And finally, step 5. Think about scale controls. You'll want to configure your Lambda function's memory and timeout appropriately. Consider adding reserved concurrency to your Lambda for consistent performance under load. And, depending on your traffic, you might need to request increases for your Amazon Comprehend TPS transactions per second. Quotas, the default is 20 TPS for these PII APIs.
Right sizing and tuning for performance. It's striking, though, how much of that is just wiring things together in the console or via IAC, not writing complex transformation logic.
That's a huge advantage. Less custom code means faster deployment, less maintenance, fewer bugs.
Okay, but let's talk performance and cost more directly. On-the-fly processing, especially involving ML services like Comprehend, sounds like it could get slow or expensive, particularly at petabyte scale. How do you manage that?
Good points. Performance first. The reference Lambda code uses a neat chunking strategy. It reads the object data in chunks, typically up to 100 KOB.
Why chunking?
It helps manage memory usage in Lambda, but more importantly, it allows for efficient use of the comprehend APIs. You can potentially process chunks in parallel, and it helps batch calls to comprehend, making better use of those TPS quotas we mentioned. You're not sending tiny bits of data one by one, you're sending reasonable chunks.
Makes sense. Any other performance tips?
Caching is another big one mentioned in the sources. The Lambda function can use its ephemeral storage, TMP, to cache the results for objects it knows don't contain PII.
So if you request the same clean object again?
Exactly. The function can check its local cache first. If it finds a known clean result for that object, it can skip calling contains by entities again. It just streams the data directly. This avoids redundant comprehend calls for frequently accessed, non-sensitive objects.
Smart. And how do you keep an eye on all this? Monitoring.
CloudWatch metrics are your friend here. You definitely want to watch the Object Lambda object metric on your Object Lambda access point that tells you your request volume. And monitor the Lambda duration and memory used for your function. This data helps you tune the Lambda memory setting, right-size it, so you're not over-provisioning and paying too much, but also ensuring it has enough power to run quickly.
Okay, which brings us to cost. What's the equation look like?
It's basically three main parts. You pay for Lambda compute, GB seconds memory allocated multiplied by execution time. You pay for the comprehend PII API calls, both contains and detect. And there's a small Object Lambda request, premium per request, processed.
So compute, ML inference, and a request fee. How does that stack up against ETL?
While it's not free, the key takeaway from the analysis is that for large-scale PII redaction on existing data, this approach is almost always significantly cheaper than rewriting petabytes using traditional ETL. You avoid the massive storage duplication costs, the heavy compute cost of batch jobs, and the extensive engineering time. You're trading large, upfront CapEx-like costs for more predictable, usage-based OpEx.
That makes sense. It's paying for value delivered on demand rather than a massive upfront investment. Okay, let's switch gears slightly. PII means compliance, GDPR, HAPA, CCPA. These have strict rules. How does Object Lambda help meet those requirements?
This is a really strong point for Object Lambda. The policy controls are key. You can put an IAM policy directly on the Object Lambda access point that explicitly denies access unless it goes through the redaction lambda.
So you can enforce that no one gets raw data through that endpoint.
Exactly. You can enforce separation of duty. Maybe only a specific admin role can access the supporting access point for raw data, while all regular users must go through the Object Lambda access point, guaranteeing they only see redacted data. This maps very well to requirements and regulations like GDPR and HIPAA about minimizing data exposure and enforcing access controls.
And the data stays within AWS.
Critically, yes. The entire process, fetching from S3, processing in Lambda with comprehend, streaming back, happens within the AWS environment. No sensitive, unmasked bytes leave that secure boundary during the transformation. This significantly strengthens your compliance posture compared to pulling data out for external processing. It really simplifies demonstrating control.
That's a huge plus for regulated industries. Now, you keep mentioning the client-side simplicity. Can you give some concrete examples? Like what tools that data teams use every day can just switch over?
Oh, absolutely. Think about Amazon Athena. You normally create an external table pointing to your S3 path, right?
Locations3.mybucketdata.
Well, you just change that location to point to the Object Lambda Access Point ARN instead. That's it. Suddenly, any analyst running SQL queries against that Athena table is getting the masked data automatically. Zero changes to their SQL queries or BI tools connected to Athena.
Wow, that easy for Athena. That's huge for analysts.
It really is.
Yeah.
Same idea for big data processing or machine learning. If you're using Amazon EMR or SageMaker notebooks to read data from S3, you just update the S3 path in your scripter configuration to use the Object Lambda ARN.
And the Spark job or the Python script just works.
It just works. It reads the data stream like it always did, but the PII is already gone. The data sets look identical to the tools, just cleaner. This zero-code consumer capability is incredibly powerful for rapid adoption across an organization.
No kidding. That frictionless integration is a massive selling point. Okay, so let's say I'm convinced. I want to roll this out. How do we do it safely in a real production environment? What's a good migration strategy?
You definitely want to do it gradually, not a big bang. Start with a pilot. Pick maybe one specific S3 bucket or even just a prefix within a bucket and one or two specific applications or workloads that use that data.
Test the waters first.
Exactly. Deploy Object Lambda just for that scope. Validate that the redaction works correctly, monitor the performance, get comfortable with it, build confidence.
Makes sense. Then what?
Then you start the gradual cutover. Begin migrating more clients' applications, Athena tables, analytics jobs to use the Object Lambda endpoint instead of the direct bucket access. You can do this application by application, team by team, monitor closely as you go.
Incrementally shift the traffic.
Right. And as you gain full confidence that Object Lambda is handling the load reliably and accurately for those workloads, you can finally decommission the old ways. If you had separate masked data copies or complex ETL pipelines creating them, now you can start turning those off and reclaiming that storage and compute.
And the whole time?
The whole time, your original raw data lake remains untouched. That's the safety net. If anything goes wrong during the migration, you can always point clients back to the original source, if appropriate policies allow, or pause the cutover. It provides incredible rollback capability and preserves that pristine source of truth. It's about incremental improvement, not a risky rip and replace.
That's a really sensible, risk-mitigated approach. Okay, let's try and wrap this up. For you, our listener, what's the big picture here? We've dug into how S3 Object Lambda really shifts the landscape for handling sensitive data in these huge data lakes.
Yeah, the core idea to take away is this. Object Lambda turns a simple S3 GET into a powerful real-time transformation engine. You attach that comprehend PII redaction function, and suddenly you bypass potentially months of difficult ETL work and avoided massive data duplication, all with what amounts to some configuration and a Lambda function.
And the key benefits really stand out.
They do. It's built to scale to petabytes because it processes on demand. It's compliant by design, helping you meet strict regulations through policy controls and keeping data within AWS, and it's ready to use today.
It makes you think, though, beyond just PII, if you can intercept S3 reads and run any code, what else could you do? Dynamic format changes, real-time watermarking, on-the-fly enrichment based on who's asking. The possibilities seem really broad.
It certainly opens up a lot of interesting avenues for data processing right at the storage layer. Definitely something to ponder. That's all for this topic. Stay tuned for the next DevOps Cloud interview question.